In this video, let's look at complex fractions, which are examples of rational expressions. So it says a complex fraction is a quotient, meaning a fraction division, having a fraction in the numerator, denominator, or both. So it's like a double fraction, a fraction inside of a fraction. To simplify a complex fraction, you first find the LCD, and then you multiply all terms. And when I say all, I mean in both the numerator and denominator by the LCD and simplify. What remains? So let's take a look at one. It's easier to actually go through one than it is just to talk about it. So here I have a complex fraction. What makes it a complex fraction is there a rational expression in the numerator and in the denominator. In other words, there's a fraction in the numerator and a fraction in the denominator. So it's fractions inside of fractions. So I'm going to look at my two denominators, x and 2x, and I know that the LCD for x and 2x is 2x. So I'm going to multiply each term of my complex fraction by that LCD. I do that by putting each term in parentheses. In this case, there's just two terms. And I'm going to multiply by the LCD over 1 if you wish. You don't have to put it over 1, but it helps to be able to see that it's also a fraction. That causes this denominator to cross cancel completely. It causes the x's in that denominator to cross cancel. Now when I write what's left, in my numerator I have a 2 times an x plus 1 over an x minus 1. There's no need to go ahead and distribute that numerator. You want to leave things in their most factored form to make sure that nothing makes a 1, nothing cross cancels. So we have our solution right there just by multiplying by the LCD. Or we have our simplification, excuse me. Let's look at the next one. This one is a little harder because in order to determine what the LCD is, I am first going to have to factor that denominator, x squared minus 9. So when I do that, my numerator remains 2 over x minus 3 because it doesn't need to be factored. But my denominator now is 5 over, I hope you recognize this as difference of squares. So it's going to be x plus 3, x minus 3. And if you remember from prior videos, in order to find the LCD, we know that each piece of the denominators have to be represented. So my LCD here is going to be x minus 3. That represents this and this, times x plus 3. I stacked those up just because of space, but it's times. So now I'm going to put each fraction, each term in parentheses, and beside it, and this gets kind of cluttered, so you just have to sort of squeeze things in, I'm going to write my LCD. Again, if you want to put it over 1, put it over 1. You will see that in this denominator, everything cross cancels. Here, that cross cancels. And what do we have left? We have a 2 times an x plus 3. And in the bottom, the denominator of the large fraction, all I have left is a 5. So it's simplified very much by using that LCD. It just looks complicated in the interim steps where you're writing the LCD and cross-canceling. All right, looking at C, I have a denominator of 3t and 3r. So my LCD here is going to be, I need a 3, I need an r, and I need a t. That will cause each piece to cross cancel. So that's what your LCD is. It's what will cause each piece to cross cancel. So I'm going to write 3RT, 3RT. Notice each time I am putting my terms in parentheses because that indicates multiplication is coming. So that's what you're doing. You're putting it in parentheses to multiply. 3 cross cancels 3, t cross cancels t. So in my numerator, I have a 2r4t squared times r. So I'm going to go ahead and multiply those two r's. So it's going to give me 2r to the 5th t squared. My denominator, my 3's cross cancel, the r's cross cancel. I have a t that I will multiply times that t to the 5th. 5r squared t to the 6th now, t to the 5th times t. Now I can simplify this further because I have r's in both numerator and denominator, and I have t's in both places. The 2 and the 5 are going to stay as they are. Can't be simplified. These two r's cross out two of those, leaving r3 in the numerator. Now notice the t terms. Let me use a different color to sort of mark those off. Notice that I have more t's in the numerator than I do the denominator. So these two t's cross cancel two of those, leaving 4, but they are in the denominator. Make sure that whatever's left over remains where it's left. The next complex fractions are a little more complicated because they have pluses and minuses in both the numerator and denominator. So the first thing I'm going to do is put my whole numbers over 1 so that I recognize what I have. I look at my denominators, a 1, a y, a 1, and a y. That's pretty simple. The LCD is just 1y. Put each term separately in parentheses like that. And write your LCD over 1 beside it. Now, at this stage, it looks like we just made things more complicated, but it will quickly simplify. In my first term, my y has nothing to cross cancel with, so what I'm left with is a 2y. The y's cross cancel there, and I have a 1 left. In my denominator, my y has nothing to cross cancel with, so I have a 3y. Here the y's cross cancel, and I have a 2. So basically, in one step, I simplified my complex fraction by multiplying by the LCDs. All right, in example E, we're going to do the same thing. These are getting a little more complicated. My denominators are 1, p minus 1, and p. So my LCD, remember, has to represent all the parts. I need a p to represent this one, but I also need a p minus 1. Each term now goes in parentheses, and beside it, I'm going to write p times p minus 1. P times p minus 1. P times p minus 1, and p times p minus 1. Now very carefully, we're going to cross cancel here. In the first term, nothing cross cancels because I have a 1. So what is left is a p times a 2p, which is 2p squared, times p minus 1, plus the p minus 1's cross cancel, 5p, over nothing cross cancels, so I have a p times a 3p, 3p squared times p minus 1, don't forget the p minus 1, minus 2 times p minus 1. Now I think it's fairly obvious that this one is not finished. It's not simplified. So we need to work a little bit further. In my numerator, I'm going to go ahead and distribute because I think I might have like terms to combine, maybe not. That's going to give me a 2p cubed, 2p squared times p, minus 2p squared plus 5p over, same thing here, we're going to distribute, 3p cubed minus 3p squared. Here I'm distributing a negative 2. So minus 2p, and then negative 2 times negative 1 is plus 2. Now the question becomes, how do you know if you are finished? Well, there's several things I could do, none of which, unfortunately, in this case are going to help. In my numerator, because each term has a p, I could factor out a p, leaving me with 2p squared minus 2p plus 5 all over. I cannot factor a p out of the denominator because this last term doesn't have one. So this p is not going to get something to cross cancel with. Now I could do a factor by grouping, and perhaps we should go ahead and do that just because I want to show you what's going to happen. Notice that there is a negative in between, so I'm going to make a correction on that last term. And what I have, and I'm actually going to move up here because I'm kind of out of space. I'm going to move up here to do the work. I'm going to factor out the GCF. Well, I don't want you not to be able to see it. I'll do it underneath. Factor out the GCF, which is 3p squared, and what you would have left would be p minus 1 minus 2 times p minus 1. So I can actually factor this into p minus 1, 3p squared minus 2. However, looking at it in its most factored form, there is still nothing that cross cancels. There's nothing over itself. So it was a good thing that we factored everything to see if it would go further, but it doesn't. This was a tough one, only because it was very cluttered with what the LCD was. Let's look at our last one. I have denominators of xy, x squared, and y squared. In order to cross cancel each term, my LCD is x squared, y squared. That is enough to represent these denominators, but it's more than enough to represent these. Remember, all you want to do is have them cross cancel. So x squared, y squared, x squared, y squared. I'm writing that LCD beside each denominator. Now this x cross cancels one of those, leaving xy squared times 1, xy squared. This y cross cancels one of those, leaving x squared y times 1 over x squared cross cancels x squared. I have a y squared. Y squared cross cancels y squared. I have an x squared. Now, this is a case where we definitely need to go further and factor these and see what we can get. So in my numerator, my GCF is xy, and what is left is y plus x, if you factor that out. My denominator is difference of two squares, so it's x plus y. Whoops, should have done it y plus x. It's okay. Let's do that. Y plus x, times y minus x. By the way, that mistake I made is an easy one to make. We're very comfortable with the x's coming first. It's what we're used to. But the order here matters very much because when I get to the minus part, the y has to have come first. So you can see that my y plus x and my y plus x will cross cancel, and we are left with just xy over y minus x.